So in this video, we're going to talk about the concept of friction. Now, friction is not a very high yield concept on the MCAT, but it is important to have some awareness of it. So we're going to talk about it here. So friction is essentially a force that opposes motion, right? So if I got something, let's say let's say we got a hockey puck, right? And we send the hockey puck sliding across ice. Well, ice is pretty slippery. And what we mean by slippery, right? The idea of slippery means that the friction on ice is very low, but there still is going to be some friction. And so friction, right? So let's say the hockey puck is moving at a constant velocity of 9 meters per second, right? Well, if a velocity is constant, that means that the forces are balanced. There's no net force on the hockey puck, right? But of course, we know that in real life, if I were to send a hockey puck sliding on ice, it might slide for a while, but eventually it's going to come to a stop, right? And why does it come to a stop? Well, the reason why it'll stop eventually has to do with friction, right? And so what that means is that friction is a force. Oh, that's a very thick marker. Friction is a force, right? Is the force that opposes the motion of the object. So the object is going to move at a constant velocity. If there were no friction, it would move at a constant velocity. But because there's friction, it's going to slow down. So it starts out maybe at 9 meters per second. And then let's say it ends up at 0, right? Maybe it'll take a while to get there. And that's because of a frictional force opposing the movement. And so friction always opposes the motion of an object. And the way to calculate friction, the force of friction, the frictional force, right? Frictional force. Or actually, frictional force is typically drawn as a lowercase f, or typically it's actually drawn as a cursive lowercase f, is equal to, and that looks like, is equal to the normal force times the coefficient of friction, right? Okay, so let's break down what these mean, what these are. All right. First of all, let's talk about what the force of friction is. The force of friction is, of course, the force that we said opposes this. And so this force of friction. Again, the force of friction always acts in the direction opposed to the direction of motion, because that's force of friction. What is, let me do this one first. What is the coefficient of friction? Coefficient of friction is a constant for two things, for a given object or for two given surfaces, right? So what I mean by that is the rubber, I think hockey pucks are made of rubber. I'm not sure. I don't really play hockey. So this is a hockey puck, right? And then let's use a different color. Let's say this is the ice, right? So this is the ice, and the hockey puck and the ice are touching each other. Those are two surfaces, right? So for those two things, the hockey puck and the ice, there would be a given coefficient of friction, right? So mu for a hockey puck, or specifically for the rubber of the hockey puck, right? And ice. And so we can't change mu without changing the surfaces. And so, for example, mu so the reason why the hockey puck slides relatively easily on ice is because mu is relatively low. Now compare that to trying to slide a hockey puck, right, on, let's say asphalt, right? That's going to be much more difficult. So mu for hockey puck and asphalt is much higher, right? The coefficient of friction for asphalt and the hockey puck and the rubber of the hockey puck is much higher. And so, okay, so mu is a constant for two given surfaces that are touching each other. Some surfaces have very high friction with one another. Other surfaces have very low friction with one another, right? Sandpaper, for example, anything with sandpaper is going to have a very high coefficient of friction, right? And typically, just one last point to make is that typically that force of friction gets dissipated as heat, right? We know that energy can neither be created nor destroyed. So where exactly is the energy of friction going? the energy produced by the force of friction, it's going to heat. And that's why if you slide two things across, if you rub two things together very quickly, you'll end up with heat, right? And so as an example, it's sandpaper. If you've ever tried to sand something, you know that some things can get very hot. You can actually burn something, burn wood using sandpaper. It's because the force of friction, energy that's produced of friction, is turning into heat. Okay, and the last point to be aware of is, of course, the normal force. What is normal force, right? Or what is what is a normal force? And so normal force, let me see if we can move down a little bit. Let's move this way so that we can. So normal force. The normal force is essentially the force that's pushing up on an object, right? So actually, let's go back this way. No, let's stay here. Let's say we've got our hockey puck, right? And we have got, and it's on a flat horizontal surface, right? Let's say the hockey puck weighs 3 kilograms, right? Well, that means that the hockey puck is pushing down on the ice with a force, right? And what is that force? The force is 3 kilograms times the acceleration of gravity, or 30 newtons. Right, of course, acceleration of gravity is 10 meters per second squared. So it's going to be 30 newtons. So that means the hockey puck is pushing down on the ice with 30 newtons. But of course, we know that the hockey puck is not moving, or it's assuming it's stationary, it's not moving down, right? If that means that there has to be a force balancing it out. And indeed, that force is the normal force, right? And so the normal force is essentially the force that opposes the force of gravity. And so in this case, the normal force would be 30 newtons, right? And so that's fairly straightforward, right? Normal force is just the force of gravity. Is this equal to the force of gravity? It's just in the opposite direction. It's just the force upward that counteracts the force of gravity downward, right? So what you do is you calculate the force of gravity on the object. And then you calculate the normal force. And then from that, you know the normal force, right? And so to figure out the force of friction on an object in general, what we do is we just do the force of friction is equal to the normal force. So let's say, for example, we have a 3 kilogram object here. And that means the normal force is 30 newtons, right? And then times the coefficient of friction, right? And the coefficient of friction, again, typically would be a given for a given object and its surface, right? You might instead be given the force of friction, this one, and then and also be given the normal force, or be given the mass of the object, and so you can figure out the normal force, and then asked to calculate the coefficient of friction. It's fairly straightforward either way, right? Okay. The last point to be aware of is the concept of static friction. And so static friction is fairly similar to this kind of friction. It's just a different kind of friction. Static friction is the friction. So as we said, friction in general is the force that opposes the direction of motion. Static friction means that an object is standing still, right? So let's say I've got a really big refrigerator, really heavy refrigerator, right? And if you've ever tried to push a refrigerator, if you've ever tried to push something heavy, you know that you stand there and you give it a push. And so what's going on there? You're pushing it and it's not moving, right? So you're applying a force, and the force you're applying increases. You're pushing harder and harder and harder and harder, right? You're pushing harder and it's still not moving. The fridge is still not moving. And then finally, at some point you're pushing hard enough, and now finally the fridge starts moving a little bit, right? So what's going on there? That's the concept of static friction. So the equation for static friction, I'm just going to write it out actually. Static friction. Let me actually use a different color so that we can see it. Static friction. Static friction is less than or equal to the normal force times the coefficient of static friction. So coefficient of static friction is not the same thing as the coefficient of friction in general. It's a particular kind of coefficient of friction. And why do we say less than or equal? So it's the same, calculating it is the same, but why do we say less than or equal to, right? What that means is that there is a maximum amount of static friction, and that's what's going on here, right? as the force that you applied to the fridge increased, so it starts increasing and increasing, right? You're applying more and more force. Well, the coefficient of the static friction, the force of static friction opposing it is also increasing and increasing, right? And so it just cancels out the force that you're applying until you get to a point where now static friction is at its maximum, right? And so now the force that you're applying is just extra force, and now the force you're applying actually causes the object to move. And so just be aware that static friction actually changes with the amount of force that you're applying, right? If you're pushing something really, really hard and it's still not moving, that means that there's an equal and opposite force of static friction in the opposite direction, right? And so just be aware of that as far as static friction, but otherwise it's the same thing. Otherwise the math on it is the same thing. And otherwise friction, this is the way to calculate friction in general, and this is how the concept of friction on the MCAT.